Draft physics video. Just a add-on, I think a little add-on on interferometers and beam splitters and whatnot. So the Wikipedia article is really thin, not much context at all, and just talks about these two basic kinds of beam splitters. One that uses the half silvering kind of idea, half aluminizing. So I guess they use aluminum, and the other one, the cubes type, which is really interesting. So clearly I don't think there's any theoretical hope for the film type that does the half mirroring, because it just kind of, the Huygens things kicks in and you're going to get a ton of divergence. This image doesn't, it shows the reflection, but it doesn't really show the transmission beam at all, so it's not a very good image. But anyway, but this cube thing is interesting in terms of the two prisms glued together, and the idea of transmitting, changing this surface so the light transmits through the reflective surface. So the idea is that basically, if you have just one of these triangles, it creates 100% reflection at the 90-degree angle. But if you can put something that contacts the flat surface, so something that contacts this surface here, the big surface, well, I have to have the camera thing on, don't I, for that to work? Yes, you do, Barry. Alright, so this flat surface. So this is all I have. I don't have two of these, unfortunately, or I could make a good little beam splitter. So I don't know what kind Hafliday has, or is getting. So I didn't order mine yet, because I really just wasn't sure whether I should spend money on something good, like a quality beam splitter, or whether I could go with something cheap. And I didn't want to spend, $15 for something I already have in terms of the cheap piece of film I already have. But anyway, so it'd be good to see what he gets. So this type, you're just gluing two of these together. So you're just gluing two triangles together, and it's the glue that creates a transmission medium. Now the other thing I noticed about it was that it also appears to be polarized. So as I turn this, you can sort of see, okay, the images screw up, but they also get brighter. So see how much brighter that is? So it appears this is polarizing the light, besides just doing this weird thingy. So when it's flat on its big side, it's transmitting. It's not 100% reflective, because it's making contact with air and the surface, and apparently that's enough. So it's like I could stick my, you probably can't see this, but if I stick my finger on here, it should change the image. You're seeing my finger, which you shouldn't be. Okay, so I have to turn it enough of an angle. It's not it's not working. Alright, I have to have this straight. So what's it? Let's see. Okay, so it's looking at my hand, and that's not going to work. So I have to hold it differently. Hold it this way, and then stick my finger on here. Still didn't work. Yeah, it's not 100% reflect there. Okay, now you can sort of see it. So there's 100% reflection, and then when my finger hits it, it breaks the reflection. So contact with the surface can break the reflectivity, changes the I don't know if it changes the index actually, but I mean it obviously changes whether the light reflects or whether the light yeah, so I should be able to draw a picture. So anyway, this picture was just the idea of, these people keep talking about these interferometers, and I just want to make sure they really think that two beams go through this whole thing, don't interfere with each other, and then something happens when they hit the last leg of their path here, and they do this wavy thingy, creating this pattern, that somehow it happens here. I just want them to say they think it actually happens here in the air, where the photons do this interference thing. Because yeah, I think that doesn't have a hope of being the truth. But anyway, so here's the idea: is you take two of these triangle pieces and you glue them together with an epoxy or some other acrylic or something. And that's why I sort of want to just buy two separate ones and make my own experimental glues to increase the transmission. So what's basically happening is, if this were the surfaces, is when you put a layer of something, you change the reflective index of these layers. And so the reflections that were 100% before doing this, 100%, because you put some glue on there, the light's going to be transmitted into the other triangular surface, and now it's going to exit through the same pyramid-y thingy and do exactly the opposite of what it did before, which I guess would be something like this, and come out that way. So light goes in this way, goes through the transmission, gets refracted the same way as it did in the other one, and so you end up with a straight path technically. Obviously it won't be completely straight, but it's, stuff goes in going a direction, stuff comes out going that direction, and the interference will just be whatever this layer is made out of will dictate your interference. Now the interesting thing is, if you change this depth, you can change what frequency light will be transmitted. So you can block light. You can force certain light to be 100% reflected, or certain light to be 100% transmitted, which is also interesting. So it creates lots of possibilities. Yeah, so this was just a, like I said, I got interrupted, so I just figured I'll do this video over. It's supposed to be just a quick video anyway, but the point is so this is what it ends up doing, because you control this layer, and you can create 50% of light goes transmitted through, so it takes this slightly crooked path, goes through, and then 50% goes this way. And there's no problem with the small aperture hole thing, so you don't have any divergence created by small apertures. So this seems to have a lot more of a hope of being a beam splitter than the mirrored piece of glass, the glass with the layer of holes on it, because obviously I would argue the layer with holes on it has to it has no choice, it has to create diffraction. So so we'll see what kind Hofflet it gets, because this one's got some hope, but still there's the whole point of what goes on inside this intermediate layer, and how much light you're actually consuming in this layer too is probably rather significant. So we don't know what light it's filtering in and out, and obviously it seems to me that it's obviously also polarized. So it depending on the light's polarization, it's also going to perhaps block 25 or 30% of the light, just because it's the wrong polarization to reflect or be transmitted. So that's a whole nother complexity. So like I said, there's nothing simple about beam splitters, and there's a lot to try to understand what exactly is really happening. That I think is obviously, it isn't this idea that you send a beam in, one beam goes this way, one beam goes this way, and then they both come out this way, and then they decide to interfere with each other. I just think that's not even doesn't have a hope of being accurate. So there's anything else I wanted to say? Yeah, there is a lot of scatter. I did notice that. So I mean, I can't really show that probably, but let's see if I can show any of it at all. I have to point this the right way. See if the beam will do anything useful here. So you can sort of see that there's a lot of whatever haze around the beam when it goes through this, and this is with just one side of it. Obviously this second side would also be creating scatter, so there's going to be quite a bit of scatter, I think. That's the beam by itself. Well, it's too bright to be useful, unfortunately. I have to maybe use the red laser for these examples. Let's see if it works. Red laser have batteries in it. Well, it's got something anyway. So that little, not particularly interesting beam is, so yeah, you don't see much of the scatter. But it's not enough light going through, so you can't see much of it because there's not enough light going through. But that would be the beam. Yeah, you can't tell the difference. So we'll see. Work in progress and whatnot, and so. But yeah, it's sort of interesting that you can change how much light's reflected by just putting something on this surface. So when it's just a glass surface, 100% of the light reflects. If you put something on there, then you change how much light might get transmitted. I couldn't actually make a beam go straight out by putting glass against this surface, with a layer of water or oil. It came out at the wrong angle, so that was sort of interesting that I can get it to produce. Let's see, is there room on here? It's a triangle over here. So it's just a triangle. So by attaching something here, I was kind of hoping I could make it do something like this and this, and it sort of does. It's just that this total angle isn't 90 degrees between the two beams of light, so it comes out sort of like that, but it's not really 90 degrees, so I have to think on that. Anyway, so just a clarification video. Different beam splitters do different things. I guess that shouldn't be too miraculous a statement, but clearly they function very differently, and that's sort of important. Yeah. So anyway, like I said, it's kind of disappointing the Wikipedia page because it just doesn't go in. It doesn't go into refraction or anything. It just, like I said, it's a very short page, and it has this ton of this. I don't even know what kind of math this is for. Lossless beam splitter. Consider the lossless beam splitter. Electric fields. Yeah. So it's all this. They're talking about their electric field and stuff, when I don't think that has anything to do with it. But anyway, there just wasn't much on the actual, what actually is happening inside the beam splitter, which I thought was kind of an important thing to go into the details about how the light, you having concepts of, internal reflections, that go on, so a lot of light comes out of weird places, because it gets trapped in persistent internal reflections. Total internal reflection, I guess they call that. But anyway, lots of stuff. So we'll have to wait and see. So I don't know, like I said, I don't know what kind of beam splitter Hoffa they got. I hope he got a coated one, just because that's the kind I think that has to diffract the light. But we'll see. Oh yeah, I might as well do those comments. That's what jeez. Sorry. Rough day. It's a rough life in general. Alright, so Hoffa said, have you ordered a splitter? No. Should have waited until it arrived. He says, well, I don't think I should wait when I have other things to play with here. It's not that, Anyway. Mine is due any day now. I bet no significant splitting divergence equals no side beams. Well, again, it's clearly in this prism type, you're not using a mirror of any kind, and there's no diffraction gradient, obvious one anyway. I mean, how exactly the glue works in terms of being a transmission medium is still open to some conversation, but clearly, yes, this beam shined through here, at least the one right angle I can create. Oops. There's obviously no multiple images, as there is with the diffraction gradient, but there is a bunch of, there are some multiple images. It's just they're not in the wrong places. Oh, I have to tap the camera on, asshole. I have to find some better way to do this so I don't have to remember All right, so there's obviously, it's not as clean as you know, there's obviously a lot of noise in this beam, but there's no divergence this way that's apparent. But then that's just doing the 90-degree turn thing. And the idea would be is when you put something else here, you can screw around with that reflective index. Let's see if I can get my finger to screw it up. And it doesn't appear to hurt the beam any. Well, you can't see it because it's under my hand. Yeah, no way to win that argument. I mean, no way to. Yeah. So anyway, but you do have light that goes in different places, and you know it's not exactly perfect. I'm seeing two images of the beam, which is kind of strange, and they're coming back this way. So they're reflecting off this surface of the glass here also. But, you know, anyway, it's worth playing with. But yeah, I wish I had a second piece. I could really get somewhere. Anyway, I'd still say that's diverging some. I mean, the further you cast that image, I mean, all laser beams diverge. So if I cast the image further away, over there, yeah, I mean, it does get substantially big, and it also has a lot of haze around it. So, I mean, a lot of haze. So there's definitely some divergence, but the beam itself doesn't appear to be horribly diverged. And then you have this polarization issue. Okay, so back to the comment. I think, sorry, not as you know, right, like my usual videos are, but anyway, it doesn't matter. Okay, so this was a link to what? This was some kind of crap. I don't remember. Damn it. Well, I'll read Hilton, get that done. And Frank Hertz, so that's the cowboy impersonating people again. So that's all he can do. He can only impersonate people. He can't actually be a person. Alright, so we'll get this done and be done with this. You still fail to correct for the erroneous assumption that a beam splitter will create rings in one of the beams, despite the fact that it is designed specifically to have smaller openings. I'm just saying, look, it's your own physics. You know, you're not arguing me, you're arguing Heisenberg. Heisenberg dictates that if you make the hole smaller, you're just going to create more and more divergence. It's not a rule I made, asshole. I'm arguing conventional physics. That's their theory. You're saying their theory, I can modify it. Heisenberg doesn't happen. If I make the hole small enough, there's no Heisenberg. I'm just saying, I don't know what else to do but say, you're full of shit. How can you possibly argue that, idiot? You know, without saying you're just disputing everything every college professor says about what light does. I mean, you're the one saying conventional physics or popular physics or whatever, the physics they're teaching in colleges is wrong. So you're the one saying they're teaching it wrong in college. And those in a diffraction gradient. So he's saying if you make the hole small enough, you'll stop divergence. An amazing statement, because frankly, like I stated, if that were true, then they could make microscopes that could work. You know, that could see more and more, deeper and deeper. And they can't, because of the very fact of this stupid Heisenberg phenomenon. I mean, obviously, I don't think it's for the reasons of Heisenberg. I think it's just because, yes, matter affects photons because matter has electrons around it, and it's the electrons that are fucking up the photons. It's partly why beam splitters are designed for specific wavelength ranges. Yes, they can be designed that way if they're this kind, for sure. Now, how much they can do with the putting the aluminum on, you'd certainly think that, yes, some wavelengths are going to be more affected than others, but they're just going to be blocked, I think, reflected. You make the hole small enough, certain wavelengths won't get through. Maybe that's it. These are things you completely ignore. No, you completely ignore your own, the fucking science you're disputing. You're the one disputing the science taught in colleges. and it renders your reasoning null. No, your reasoning is null. Again, I don't know how many times I have to say Heisenberg. How many times have I said it? Why don't you make an argument relevant to that principle? Do you think that principle is real or not? If you think it's bullshit, then just say in words, Heisenberg is bullshit. But don't play this fucking game like you can pretend it's bullshit without saying it's bullshit. Fucking. Anyway, this is something you're still failing to account. No, I'm not accounting for your wrong interpretation. You think some fantasy thing like that is true. It's not true, and so you're wrong, and that's just a fact. And it's pitiful to see you call others rude and arrogant. Well, you're obviously rude and arrogant. You're declaring a truth. You're declaring other people have misunderstood something when you're clearly the one who doesn't understand the implications of Heisenberg as a principle, dumbass. When you're making the same fallacious, again, this is fallacious comparison, as always. It's stupid to compare slits to slits, small openings to small openings. That's stupid. Holes aren't apertures. Is that what you're going to say next? You're going to say something idiotic? I don't know. I suggest you stick with your original proposal. No, I suggest you grow some integrity and quit pretending you're an expert on this subject when you're clearly not. You're just talking shit. You don't even bother to do the research, and you're just claiming that because it works, it must work. Because it works. Well, the whole point is describing why it works, asshole, and you're failing to do that. That one of your beams will have rings around it and will be 3x larger. I don't know where that came from. And don't weasel your way out of it. Where did I use the word 3x larger? I showed in the fucking video how with the diffraction gradient, with anything that has small apertures in it, it's a fucking hell of a lot more than 3 times wider. That beam is thousands of times wider than the single laser beam. Thousands of times. Well, you can't see it. I don't have the video camera on. Fuck. It's just so irritating. So I gotta find a quick way to do this, but I don't know what it would possibly be. Except to have to do the switch. But yes, this. Come on. That's a lot more than 3x wider than one of these, and that. That pattern from here to here is obviously a lot more than 3x, asshole. So I don't know what you're even talking about. Dumb fuck. Rude, obnoxious fucking bastard and such. Alright, back to this shit. Now, where the hell was I? Alright, 3x larger. And don't weasel your way out of it unless you want to explicitly state something down the line that this specific proposition isn't true in binary logic. What are you even talking about? I'm just pointing out that when half-silvered mirror is used, it can't logically, it can't help but diffract the light. And you think that's a statement that's inconsistent with some proven theory in physics. And I'm saying, no, that's exactly what they say they have proven, you fucking asshole. Alright. Figure out a little common courtesy. Obviously, you're the one that has come to my house and been a rude fuck. I haven't gone to your house and talked arrogantly and shitty to you. So, I mean, these people are so preposterous. They initiate an obnoxious conversation where they make declarations of being right and they call somebody else wrong. They don't provide any substantiation for their claims, and then they call somebody else rude for defending themselves against their obnoxious declarations that, why aren't you completely impressed with my knowledge? Didn't I prove how I'm an authority on this subject? No, you didn't demonstrate anything. All I get is your crappy, raggy comments saying you know something. And then you don't demonstrate that you know anything, but you can't tell me how the fuck this Heisenberg shit actually works. How the fuck it turns on here and it turns off where you don't want it to work anymore. The fact that you think pulling out a diffraction gradient and seeing peripheral beams going to the sides is enough to make conclusions about beam splitters. It's obviously not enough to make conclusions about all beam splitters. I can't. How many times did I say half silvered? How many times did I talk about the half silvered beam splitter? I'm talking about one specific kind of mechanism for creating a split beam. This is a different kind, the cube kind. They're different, and I think they both have their individual liabilities, quite obviously. But we'll see. Is a testament to your recklessness. Now, again, it's your recklessness, not to make a distinction between these very different ways of creating a phenomenon. And I'm just going to, again, state clearly as possible. Why don't you explain to me how Heisenberg turns off, that you can make holes small enough and then Heisenberg doesn't the truth anymore? Because, again, I'm sure the optics people who make microscopes would like to know about it. If you have some special way, if they make the holes in the, if they make little spots on the lens small enough that all of a sudden they can see with a microscope again. Not anyone else. And your rudeness just digs you deeper to anyone with an ounce of experience. Well, anybody with an ounce of honesty and integrity can understand that that kind of rhetoric spilt by you here is essentially heckling. You show up here and heckle me with your superior knowledge, okay, and demand my attention. I have to pay attention to you. I don't do that on the internet. I make videos, people have to press the button, and then they have to sit there and watch it. In any moment they can say, fuck this, I'm not listening to this asshole. He's rude and obnoxious. He's treating me like shit. You're the one doing that. You're a fucking heckler, asshole. You don't understand what it's like that you have to show up at somebody else's house, you actually wipe your feet on the rug, even though you might hate them. You know, you do these little courtesies because, yeah, that's the only way you can engage with other people. But why would they put up with you otherwise? Why would I put up with your obnoxious trolling, okay, if you can't at least do it courteously, with a little bit of courtesy, you fucking cunt? You don't ask questions. You don't say, well, how do you think that's possible, when I heard Professor Lewin say, well, why don't you give me a Professor Lewin quote that demonstrates that you can make really tiny apertures that no longer, Huygens and Heisenberg are no longer in effect. Anyway, even further, it's interesting to see you mention that those interferometer rings don't look anything like Newton's rings. I'm saying that there's a thing called their interference pattern, and the interference pattern has a certain profile, okay, which is it's kind of even. And those rings aren't even. They get smaller as they go further out, and they're not proportional even moving that way. There's no function, there's no linear function describing or profiling their transition. Fuckhead. Anything like Newton's rings. When you were the one to make that comparison first, that's your failure, not anyone else's. There's no failure. The point is that Newton's rings are an illustration of interference. That they're exactly the same thing as, well, look, see, this is the point you get into the argument over. There's different ways you can create Newton's rings. So I guess you have to be really careful about what you call the ring phenomenon, because it's not the same as the lensing phenomenon. See, Newton didn't believe in any of this wave theory, you know. So I mean, when he was describing the functions, it was all refractions inside the glass that were creating the multiple patterns, the multiple images. So you have to go all the way back to that to figure out which one is which. But obviously the small aperture Newton rings are the same. Those rings are the same as the rings created in the single slit, the lines, because all the single slit is just taking a piece of the circle. It's just showing you one section of the same pattern that would have been rings if you did it as a circle. So instead of creating a rectangle slit, if you would have just made it a little tiny hole, you would have gotten the rings instead of the bar pattern. You don't know that? Okay. So the Frank Hertz, this is the cowboy disguised again. The answer is simple. The diffraction grating is showing you that dots to the side because there are lots of straight line slits. that's technically true. That's why there are those dots, right? So it's just a multi-aperture fringe pattern. Is that too much for you to understand? Is it? But when those slits go in all directions, those dots are going to become rings. So you can't understand that. So if it creates dots in one row this way, and then you change the slits to be every direction, that the dots would go in every direction, and they would create rings. So that's too big a jump for you guys. Alright. He's right and you're wrong. He's being sarcastic, that somehow I'm not right about that fact. And you should have had more caution. You should have realized the tons, tip and tap, slip and slide, hoopla, hoop. Yes, in opposition to the silly theory that the tons, wavy, whoppy, sloppy poppy through the space and somehow don't interfere with each other, but interfere with a copy of themselves. Yeah, okay. And limbo, jump scotch, and pole vault their way through the slits. Yeah, so let's understand that your theory isn't just that two beams of light get split, but that somehow this beam doesn't really interfere with this beam. No, this beam interferes with itself. So somehow the one that went this way, this photon gets to the surface, and it doesn't interfere with this guy. No, it interferes with itself somehow in a way that would look just like he interfered with this guy. That's your theory, fucknut. So, again, you still, you people just keep ignoring your own physics, right? So just, Huffley, you're the spokesperson for these idiot trolls. Why don't you just overtly say that you think this interferometer is about two different photons? That is, two photons are split. So they go in the same, they split directions. One goes this way, one of them goes this way. And that somehow those two different photons interfere here with each other to create the pattern. They don't interfere with themselves as they're doing in the single slit experiment. So you're basically saying that if I do an interferometer experiment with a single photon, it won't work. So you're saying that if you put a single photon in, 50% of the time it'll do this, 50% of the time it'll do this, and that over time you can't build up exactly the same pattern with single photons. Is that your argument? That it's not single photons interfering with themselves? Is that your that's quantum mechanics, shithead. So if you're going to defend quantum mechanics, defend quantum mechanics. Don't pretend you can change the rules for different experiments and create a whole new physics based on a whole new pile of crap. Alright, so I did this definitive statement shit. So I think we're got enough here. Flat earthers are fucking pedophiles. Flat earth could prove me wrong. Well, anyway, flat earthers. So obviously, if you're wrong about one thing, you could be wrong about a lot of things. So yes, it's probably likely that flat earthers are. There's probably more of them who eat dog shit. Probably more of them than the average population fuck dogs. They probably do lots of things wrong because they obviously can't get something simple like the earth isn't flat right. So the fact that you have one broken piece probably means you got some other bits that are broken too. But it's kind of a useless argument, frankly. I don't know if I want to do Michael in this video. I mean, it's two slit stuff, but he's going back with, to a flow, and then there would be friction, and, I don't want to do a two slit argument here, so I guess we'll just save that for some other time. Sorry, this video went longer than I intended. A lot longer than I intended. So, anyway, shit happens.